everyone wants the recording. So now we're going to start with lecture 7, rotational motion 2. Coach, yeah, okay. So basically, this is never a good. This is an okay quote to listen to. Uh, I don't. I mean, this is my first time, so basically, I don't know what we do here, but I know exactly what I'm supposed to explain today. You do not need to take notes. Your main focus is understanding, and you can just like. Okay, so basically, this is not too important. Nothing too important. So basically, what you have here is the most important part. This is centripetal acceleration, whatever you like to call it. And basically, what it's measuring is basically acceleration. This is a really good diagram. The acceleration, say when something is going in a circle, the acceleration going inwards into the center point. That's what centripetal acceleration is. And what that is basically v squared over r is the linear velocity divided by the radius of the circle. Do you guys understand what I'm saying here? You guys understand what I'm saying here? Okay, yes. That's pretty simple to understand. It's just literally just v squared over r. It's just linear velocity, and then it's the centripetal acceleration that's going inward into the center of the circle. So basically, the centripetal force is applied onto the centripetal acceleration, and basically what happens, it's not, centripetal force isn't really a real type of force. All it really is measuring is the tension in the rope or whatever like you're using, but basically is that when you spin something, it's basically just the tension. Like when you say you're using string, or say you're using technically on Earth you could do the same thing, but yes, that's basically it. And then it's basically caused by centripetal acceleration. All you have to do is, because now it's just F equals ma, so you're just doing mass times the centripetal acceleration, so it's just mv squared over r, as you've seen here, F equals ma, and that's basically it. It's not, just think of this as tension though, it's a tension force in reality. Just think of this as tension, because what is happening is that it's basically tension to keep it from flying off, that's basically what it is. And then keep in mind that this net centripetal force is in the radial direction. So it means that it's going into the center. Just think of it as going into the center of the. Just think of it as going into the center of this of a spinning object. It's always going into the center. And basically, you need to understand Newton's rotational second law. You know that you could technically call that delta F is equal to ma. I call it delta. You can call it whatever you like. Delta F is equal to ma. If you're wondering if this is a rotational equivalent of this formula, it quite is. It's basically just torque is equal to I times alpha. And what this basically means, I believe it's RF sine theta is another way to write it, if I have a whiteboard open. Do you guys understand? Do you guys want me to write that down? You just want me to say RF torque? You just replace it, and it just torque is equal to I times alpha. You could also do, I use RF sine theta, but you can use this in this. You can use this in this case. It ends up as the same thing. Do you guys understand that though? Yeah, I think I'm going a little too fast. I don't think I should be going this fast. And that's basically it. Do you guys understand what I and alpha are though? I'm pretty sure you guys understand this. You guys understand I times alpha? Okay, now I have to explain this to you. Wrong thing. You need to know torque is equal to I. Oh my god. So some of you guys are a little bit late, but it's perfectly fine. Torque, if you look at here, it's basically I times alpha. If you just, it's pretty easy to understand once you look at this. And basically what this is, that alpha is equal to, wait, what don't you understand? What don't you understand? What don't you understand, Naren? Oh, alpha? You don't understand alpha? That's what you. Oh, okay. Then alpha is basically, I believe. I don't use this. I don't use alpha formula, but I don't like to use alpha because that's I use a different equation. But yes, you need to know what alpha is. Oh my god, why doesn't it show this? god, this doesn't help me. This is basic. Well, this is what I use. I use R times F. That's what you can think of it as, but I don't usually use alpha. Alpha is basically this over I, but like alpha is basically a placeholder, which I think I forgot this ages ago. I think I remember. I think it's angular acceleration. I think yeah, it's angular acceleration, and then I is basically the mass. Yeah, it's basically the mass. And wait, is it? Wait, I thought is I's moment of inertia really? Oh well, then I'm forgetting some of this stuff. But yeah. Wait, I thought. Wait, you can talk. I thought. Why? Okay. Well, basically it means torque is equal to I times alpha, which basically just means moment of inertia times angular acceleration. There is a formula for moment of inertia, but are we gonna get into that? I don't think we should. I don't think I'm getting into that for this lesson. And basically, that it's not really applies to machine, but it's a really cool fact. What you basically you just need to understand mv squared over r. You can also think of this equation as rf sine theta. That's what I think of it. Rf sine theta is how I like to think of it. F is not. F is not. That's basically how I like to think of it, though. And then basically we have a live quiz now, but like I have no idea. I'm not prepared. Okay, go to Kahoot.it and join the live quiz of this game code. When you move on a different, if you wait, I thought. Can someone help me here? I have no idea how to do
Yeah,
that part.
what do you need? What do you need?
Um, I the Kahoot.
Oh, okay. Just a sec. Wait. So, guys, real quick. You typically wouldn't use uh torque equals moment of inertia times angular acceleration in simple. Typically, what we would use is torque equals radius. I'll put it in the chat times force times the sine of theta.
Oh
So,
yeah, that's what I used to.
like that formula. If you just search up torque formula, you'll get the same thing.
Yeah.
Okay. I think we need James for the code because I didn't make that Kahoot, Howard. So I'll ask him.
Now you guys can see my chats, and now you can understand that I'm gonna talk to James and ask for the Kahoot link. James is in his class, huh? Technical difficulties because I'm a sub.
Wait, Howard, I'm sure there's something like on Kahoot if we just search up like angular rotational motion.
Okay, shit. I'll go to Kahoot. Oh, wrong thing.
Wait, one second.
Oh, wow. You need to. I think. Wait, James made a Kahoot link though. I think I'm supposed to have access to that folder. No, this doesn't help me. We don't have the Kahoot link. Well, I think the Kahoot link was supposed to be made as the main activity. Wait, this isn't helping me. I don't have access to the practice problems either. Um, These things happen when you have sub. I guess I'll explain more of. I think everyone understands centripetal acceleration and centripetal force. It's pretty easy to understand, and you pretty much already. I wouldn't this torque formula. I don't really like. I mean, I don't use I times alpha because when you use moment of inertia, there's a completely different formula. I believe it's called some. I have it written down somewhere, but it's a completely different formula to find I, and that's something you would use if you knew the moment of inertia at a different point. That's basically what you would use I for. Usually, as I've said, it's just RF sine theta. And I mean, there's not much but to look at the practice problems, because that's the only, because like it's pretty simple to find. Oh, you found the Kahoot, I thought? Okay, okay. Okay, everyone, copy the code. I thought you can start presenting then. Wait, what? Wait, then I can't even. Wait, because I'm screen recording, am I able. I can't play this, can I? If I'm screen recording right now. Oh well.
Howard, you probably can. It's just okay. Just make sure the loom is on the Kahoot so that you're recording that at all times.
Oh, I'm not
Okay.
using Loom. I'm using an entire desktop screen recorder. Oh, that's fine. I'll just shrink this
That's
tab
okay.
to.
If you just go to the Kahoot, it should be fine still.
Yeah, I'm just gonna make it a
Um,
tiny tab in the corner. That'll work out if I put a tiny tab in the corner.
yeah. Wait, I might have found the practice problems too. Just a second.
Yeah. That's what happens when you
All right,
invite a
should I
sub.
start? Is that everyone? Well,
There's 9 people you expect. Please don't include me in that number. I just did it because yeah.
Ashik joined the Kahoot.
We need to populate our numbers.
Yeah, sure.
I mean, everyone should have access. Wait, to it, I guess. That's for you to find out, Naren. We're not gonna tell you how many questions.
We have no idea. Naren.
You should have just answered with the mysterious tone, but sure, we can. Yeah, we truly have no idea. Wait, what is this Kahoot even about then? Is it on torque or what is it on?
Yeah, it's about rotational motion.
Oh, okay, that's good then.
Okay, Howard, I can take over with the practice problems because I found them. Okay.
Yeah, you can.
Yeah, they were on the machines lecture slide, so I don't know why James didn't tell you.
Well,
Okay, I'm gonna start
James.
now. No, don't
Literally,
start.
James says it's fake news created by him. Oh my god. Oh well, it's fine.
Naren, are you gonna join?
He's on there.
Oh, he is? Oh yeah. So then why do you say no? Don't start. Soham, join the Kahoot. It's the.
He doesn't have access to the chat. I'll just repost it once I scroll down on the chat. I'll just spam it on the chat then.
Oh my God, Howard.
Oh, James.
James actually joined now. James, why?
James, if you could join, then Oh wait, he rushed on his health test. Oh.
James, we're fine. But it's okay.
Yeah. When we
Yeah,
have
we're
four
fine.
teachers.
James, we have your slides. It's okay. We got this.
Oh, we're also using the other formulas? Sure.
Okay, I'm gonna start it now.
Sure. 25 questions. Oh wow.
Okay, we'll only do like the first 15, I guess.
What's
guys remember the formula for torque, it's force times radius times sine of theta. So if the radius is larger, like farther from the axis of rotation, meaning the radius would be larger, that means the torque will be greater. Closer to the axis rotation, just that just means that the radius will be smaller. Okay. So only two people got that, but okay.
That was faster than I expected.
You guys should know this. You don't need center or mass for simple machines. Although that should be pretty obvious because
Oh, there's one
like
person and in the back. Oh.
you wouldn't really put that in the back, but okay. Come on, guys, we just covered this. Please get this. Rotating object. Remember rotating. Good job. It's not divided by its time. So remember that the formula for force is mass times acceleration. So if you replace that with moment of inertia and angular acceleration, you get the same formula just for a different like thing. Ashik, you didn't get that? Come on.
Oh, oh,
I
oh.
I read the answer wrong, okay? I'm sorry.
You put divided by?
On accident.
Okay, remember this is reference frames, and you guys really shouldn't be knowing that yet, but it's okay. Oh my god, Ashik.
Oh, Alice is beating you.
Alright, if
Wait,
you guys
what? How are we
remember,
supposed to calculate it this fast?
like, just remember the formula for angle.
I'm sure that, never mind, this is possible.
There we go. Got it.
Okay, so just to be clear, it's very simple. You just multiply all three numbers. That's all you have to do. Yeah, that's basically it. Because angular momentum is mass times radius times velocity, right? So
You gave like 3 seconds for every question.
No.
duck flies. Okay, buddy. Okay, please get this, guys.
Negative.
Okay,
Wow,
guys.
Sheik. Wow, Sheik. Wow.
Guys, they're
Click
going.
the wrong thing.
Guys, the duck is going against the wind. Therefore, you have to subtract the wind speed from the duck.
Wait, did you guys actually believe?
Ashik, you're getting crushed right now. Dang.
I know.
So remember. Well, we haven't covered moment of inertia, so I don't expect you guys to get this. Okay, good. But like, once again, I don't expect you guys to get this. Okay, good job, Ashik.
Okay, I'm gonna leave. I wanna see this. I wanna see this question.
Okay, leading velocity versus time, what SI unit that is. Good job.
Good job,
For
everyone.
those of you who put square, if it's a velocity versus time graph, you have enough information to determine the acceleration. Alright, so you guys should remember the angular velocity formula. Remember, it's in terms of radius. So if you decrease the radius, what happens? Basically, that's what the question is asking. Good job. So those of you who said decreases, it's inversely proportional, right? Because if you put your weight...
Adar, I
Yeah.
think this may be too hard. This is like conservation of angular momentum.
Okay, should we switch it? I mean,
Whatever. Just keep going.
it's good that they're learning, I guess.
Yeah, but seven people got this wrong. You're gonna need to review.
Okay, angular velocity, the formula, everything is based on the formulas, guys. Like, so if you, okay, angular velocity is just, wait, what was it again? Like,
Darb, you
yes.
have to use conservation of angular momentum. So I don't think they know that yet.
Fine, I'll just go to the slides, okay?
What?
Forget the code. Okay,
Hey.
our winner is Ashik. Second place was Alice, and third was Albert, okay? Um,
Listen, I just left for the last two questions, okay?
Okay, so then we'll go to like the machine's lectures now, like the actual stuff. Okay, um, here. So first of all, don't take notes. James said apparently these are James slides. Okay, so yeah, um,
You're using the wrong one.
I know Howard. There was no practice problems on the other one, James. So yeah.
Wait, what?
Yeah, so anyway, so centripetal acceleration is Howard. Wait, Howard, you already went over this, right? Or
Yeah.
okay, and then central. So you should take screenshots of this or something because you won't be tested on it in simple machines, but it's good to know. Um, acceleration just equals velocity squared over the radius. If you think of it in terms of regular acceleration is just change in velocity over change in time. Um, so yeah, okay. Centripetal force. It's caused by acceleration. It's mv squared over r. So you can derive it using F equals ma. Just take screenshots of this, guys. So you can refer back to it later. So now let's do some practice problems. So you'll need the formulas for these. So just to be clear, so centripetal acceleration is v squared over r. Centripetal force is mv squared over r, and torque is, you can do it in two ways: moment of inertia times angular acceleration, or sine of theta times force times radius. So if you think of torque like work, right? Because work is just uh, force times distance, but you need to add the sine of theta in because it's at an angle. Okay, so this is our first practice problem. So you want to find the speed. So remember that that requires those uh, formulas for both angular velocity, and you might need to use kinematics. I'm not sure. Hold on. Initial speed t. So going back to our formula, centripetal acceleration is v squared over r. Force is mv squared over r. All right. So what did we get? So for 39. Yeah, guys, don't worry if you don't get these because anyway, you're not going to be tested on this for simple machines. It's just so that like we can explore further stuff in physics in general. James, if you can't solve it, then why do you expect them to solve it?
Well, you could solve this.
No, James said he tried it and he couldn't.
No, I said I didn't try.
Oh, I was
Oh,
like, I'm
okay.
pretty
Just a
sure you can
random
solve this
angle.
though.
You're building the answer key to this right now.
No, there is an answer key. This is a physics Olympiad problem.
All right, so you're solving it right now.
I mean, you could just use your basic kinematics, right, guys?
That's pretty
Yeah.
big brain.
Like, okay, the kinematic you'd probably use is to find final velocity, right? So if you're given initial velocity and you're given acceleration, instead of time, you're given angle of 55 degrees, but that shouldn't really matter. But you could
Don't
just
you need
replace
v
time
squared
with
is
that.
equal to v0 squared plus 2a delta x?
I was thinking, why don't you just use v equals v naught plus a acceleration times time?
We don't have.
Because you're given v naught, you're trying to find v, you're given acceleration, and time you can just replace by sine of 55 degrees.
Oh, you could do that. Well, either method actually works.
All right, so did you guys get your answers yet? Okay, 556. Let me check that really quickly. So, um, so, or let me do it in the chat, right? So, v equals v naught plus at. Time is just a sine of 55, right? Sine of theta. You just replace that in rotational. So v naught in this case is 17 plus 9.8. Wait, James, am I right? Wait, my bad. That doesn't make any sense. Wait, James, do you know? Do you get it? Because I
Oh, I
replaced.
know how to do it. You're supposed to find the radius. You need the radius, and then you can find the part of the angle that's 55 of the circumference.
It says that the average acceleration is directed straight downward. I think that's kind of important.
Wait.
I think you're supposed to use mv squared over I. I mean v squared over I. Because at that point of 17 meters per second, it's pointed down with the centripetal acceleration of 9.8. At that point, initial speed. Because
Yeah,
everything
so
is on. Yeah, so then you know R. And then you would know the circumference of 55 because it's angle 55 of it's like that 55 degrees portion of the circumference, and then you would know x, and then you would just plug it into v squared is equal to v0 squared plus 2a delta x, because x is just the traveling on the circumference.
Wait, James, did you teach them the rotational kinematics yet?
not really. But I don't think you need that. You don't really need much for this.
You don't actually.
Oh, I get it. Okay, I get it. So basically, what you're trying to do here, I wish I had an iPad or something like I could draw in. But okay, basically, just draw the vectors, right? We went over vectors in the first lesson, and if and with the vectors, we get like this right triangle. Okay, we get where the first vector, the hypotenuse vector, is v. the leg vector is v naught, and the other leg vector is 17. One of the angles is 55. So then to find to find v, you're trying to find v, right? So then find v, you just get 17 over the cosine of 55 degrees, if I'm correct. Because okay, if you just draw a vector triangle, how do I show you guys that? Yeah, okay. Let me make a new Google Docs and maybe I can draw it there. Okay, so in this case, let's just draw a vector train, like all the vectors here.
Wait, what were the answer choices again?
Wait, Dar. I think you're supposed to use v final squared equals v naught squared
Yeah, that's
plus
exactly
2a
what I was
naught.
talking about. You can find radius using v squared over r.
I mean, if you draw the vector train, I got
Dar,
29.6.
you're supposed to set v squared divided by r equal 9.8.
Yeah, James is on the right
Then,
track. That's exactly what I
and
thought.
then you know what r is, so you can find delta x, or how much how much it has traveled, and you know the average acceleration. So you have everything you need to find
Yeah,
the
yeah,
stuff.
that's
Okay, just
basically all
hear
you
me
do.
out here. Okay, just hear me out, okay? This is 90.
I got like 29, so yeah.
Yeah, I got 29 too, but this is, in my opinion, this is probably simpler. Look, um,
Okay.
if you draw all the vectors that the thing is traveling in, 55, you're given 17 here, and this is v naught. This is v. So all you really have to do in this case is, look, v equals 55 divided by, no, wait, 17 divided by the cosine of 55. Because you'd start out with cosine of 55 equals, so 17 over v. So then you could just move it around. So you get 17 over cosine 55. And that's your final answer would be 29.6. Or you could use the kinematics like Howard said. I guess I was using the wrong kinematic. So you can do this or the other kinematic. Howard, do you want to explain that?
Oh, sure. I guess, do I start presenting or?
Or
You can
okay,
use the whiteboard.
Alice, yeah. So in my opinion, it's easy for me to draw out the vectors so that you could make some pattern connections with them. So yeah, you need to, because the way it's traveling is you split it into the two force vectors, right? It's tangent to and it's going down. So that's so it's going down with the velocity of v, and the tangent is 17. Your initial velocity is here. But Howard, you should explain yours because it's better to use the formulas probably.
Okay. Well, then you need to start. Wait, do you want me to explain out loud or do you want me to present the screen?
You should probably present then.
Oh, then you need to start presenting because I can't
Oh,
do
right,
it.
right,
Yeah.
right.
So basically, that's circular. Ignore that. So basically, what happens is that you know that v squared is equal over r is equal to centripetal AC centripetal acceleration, and in the case that we have this circle, and that the ball is at the whatever the I forgot what the object was at the top, at its initial point at the top directly that remember this 9.8 meters per second squared is always going to be pointing down. Meters per second squared is pointing down. So at this exact point, at its top, there's actually the centripetal force is 9.8 meters per second squared. So that means that, and we know the initial velocity is 17 meters per second. So this means that all we're going to do is we know the radius now. We just have to plug it in to become 9.8 is equal to v squared over r 17 squared divided by r. And you should be able to find what r is from this equation. I believe it. I believe it's just 17 squared over r, which is 9.8, which is just equal to like 29.48 or something around that number is equal to r. And when you reach r, and we know that there's supposed to be a 55-degree angle here. So then we can just find the circumference and apply a ratio to find the length of this length. So we just have to multiply the radius by 2. So we just know that 2 pi r to find the circumference times 55 over 360.
Basically,
Yeah.
yeah, so to explain real quick, so basically what Howard's gonna do now is after he found the radius, he's gonna find the distance of that 55-degree angle, and you do that by finding the total circumference and then finding the ratio of 55 over 30. So you can find just that portion.
Yeah. And then with that, and with this, basically you can just plug in the numbers, and then if you plug in the numbers, you get I have to redo this math because I erased it.
Or I can do it. Don't worry.
I think it's 28.308. 28.308. And now that you have the circumference, you have this. Let me do a different color. Now that you have the length of this, that you just need to apply that to the formula v squared is equal to v0 squared. I call it velocity at 0 plus 2a delta x. I think you guys know what delta means already. It just means total distance, or some in most cases. So that you just have to plug in. We know it literally says the average acceleration is 9.8. So you can just plug in 9.8, and you already know v0. We know v0 is 17, and we know x is the number we got here. So we plug all these numbers in, and v squared is like equal to, if I can 17 times squared plus.
No, James, don't give them the solutions yet. We have more problems too.
James a very good man. That's like 843, and then when you square root that, you should be able to get
29.6.
Yeah. When you square root like the entire answer, like 843 point something, like something, you get v is equal to, well, I actually need to do this. V is equal to 29.6, around there.
Yeah, okay, so that's probably the better way to solve it because you're actually utilizing the formulas. And then our next question is, what is the time for this motion? So that should be pretty easy
That should be
because
pretty easy, actually.
yeah, you can use the another kinematic equation, because you're given v. Well, you solve for v. You're given v naught. You're given acceleration, and you're given change in x. So really, you just have to solve for time, and you can do that in using any of the kinematic equations. So I like this one, using this one. So you can rearrange it so that t equals v0 minus v over negative a. Okay, and then you can rearrange it a little bit more to get this. And since you're given the puzzle pieces, you just plug in the numbers.
Do you want people to see your screen?
Oh, I put it in the chat.
Oh, okay.
Yeah.
Oh.
So 1.29 should be correct. I'm not sure. I didn't do the calculation. Let me just check real quick. Using that equation,
That just utilizes v is equal to v0 plus at. But yeah.
yeah, so the second part of the, if you got the first half, the second part is super easy. Um, yeah, so it's 1.2857. Yeah, you guys got it. So that's good. Okay, so now this is our next one. Okay, this seems really hard. Hold on.
Wait, Adar.
Yeah.
I think the actual answer is 2.48 seconds.
Wait, what? How's that possible?
The answer is 2.48.
How does that even work? I rearranged the kinematic. That doesn't make sense.
No, you have to use 2D kinematic. You can't just. I don't think you can just consider like different directions.
Oh shoot. Okay.
You have to like consider components and stuff.
But you didn't teach them the 2D, right?
Okay, I guess we can skip that or whatever.
Yeah.
Wow.
I mean, once again, I mean, if this was actually taught for simple machines, we'd be taking more stress over this. But it's not really that important to know for the event itself. Honestly, if you guys want, we can just go to advanced formulas right now. We have 7 minutes left.
Wait, do we even have slides for that?
Yeah, we do. Raymond and I
Wow.
made them. Okay, so I'm gonna start for advanced formulas, because honestly, this isn't like very planned out. um, but yeah, Raymond, we have 7 minutes left or six now, but Raymond will like come tomorrow and help me explain the rest. Okay. So guys, please like take screenshots or notes on this because these will probably be tested in some way. So normal force is pretty simple. It's just the force that an object is um, exerting without motion. So it's just mass times gravity, so 9.8066 whatever. But on an inclined plane, it's a little different because it's mg times the cosine of x, where x is the angle of incline. So you can think about it because if x was just 90 degrees, meaning it was perfectly over the ground, then it would cosine of x would just be 1, right? So it changes depending on the angle of incline. So that's one thing. And yes, you'll be allowed to get scientific calculators at the event itself, so you don't need to like memorize cosines and stuff. That would be like really crazy. But yeah, friction is uh the coefficient of friction times normal force. So if you recall, normal force from just now is mass times gravity. So it's just the coefficient of friction times mass times gravity if you want to expand it out. Um, Momentum is m mass times velocity. I think we've already covered this, but just to be sure, it's different from force because remember, force is just mass times acceleration. This is mass times velocity.
I just wanted to mention that momentum is a vector. You could have an x component of the momentum and y component of the momentum. And if you're doing conservation of momentum, you have to consider x and y components separate.
Yeah. So I think tomorrow we'll be doing practice problems for each of these, so be ready with the formulas. Impulse is change in p. P is momentum in physics, so change in momentum equals so impulse is just a change in momentum basically, and it equals force times the change in time. So it's essentially like how much the momentum changes in a certain period of time. Okay. Mechanical energy, if you recall, kinetic energy and potential energy, it's just if you add both of those together, so you get 0.5 mv squared plus mgh. And if you're confused on any of these formulas, feel free to stay afterwards and I can explain them in depth to you. And by the way, mechanical energy stays the same no matter what, because no matter what your position is, because if you're higher off the ground, then your mechanical energy will be, sorry, then your kinetic energy will be less. So it always balances out to be the same thing. Types of collisions. So this is pretty important because at first for me it was really confusing. So make sure you understand this part. An elastic collision is where there's no loss in kinetic energy and momentum is conserved. So basically, kinetic energy and momentum stay the exact same in the collision. So if you think of a frictionless ideal world, all collisions would be elastic because no kinetic energy would be lost. Then we have inelastic, where kinetic energy and momentum are not conserved. So it's just the opposite of an elastic collision. It's typically what happens here on Earth in a non-ideal world. If you have like two blocks or something and you push them together, kinetic energy will be lost. Um, and then tension is mass times gravity. It's pretty simple.
Um, I don't think there's no formula for tension. It depends on what you're looking at because tension is you can just like use a free body diagram and just draw an arrow for tension, try to figure out what it is. Like if it's in equilibrium and stationary, then you can figure it out using a free body diagram. But there's no like actual formula.
Okay, and then buoyancy, this won't be tested on simple machines, but it's just a good formula to know in general. So it's
Density.
yeah, if you're in density, you should probably know this.
It's basically density times gravity times volume displaced, but same thing.
So it's the density times gravitational acceleration times the volume that's displaced. Okay, and then last one, we've already covered this, but angular momentum is the moment of inertia times angular velocity. Okay, so now we have the problems, but those are saved for tomorrow. Make sure you have all these formulas like memorized, or if you need it to be, you can just have them in your notes or something. We'll be going over those problems tomorrow. That's pretty much it, I think. Sorry about the rotational motion fail because yeah, okay. All right, I think that's it. 11:20. Thanks everyone. Sorry about the rotational motion thing.